All right, we're on the last category, category 5. We have about 10 questions to go through, and we'll be done with category videos. So, category 5. The graph of quadratic function g is shown below. Based on the graph, which two values of x is a 0 of g located? Remember, zeros are where it crosses the x-axis. So it's not giving you actual zeros. It's saying your 0 is between two numbers. So it's between -1 and -2, and it's between 4 and 5. So there's your answer. 13. The table of values for quadratic function. If 1 is a solution where it's 0, what's the other solution? So it's asking for when the function equals 0. It's saying right here at 1, it equals 0. So it's asking what's the other solution that it equals 0? Well, it's 3. It's just trying to trick you up. Straightforward, but trying to mess you up. Number 18 was one of the most missed questions on this test when it was taken in 2014. A farmer uses a lever to move a large rock. The force required to move the rock varies inversely with the distance from the pivot point to the point the force is applied. I think we even talked about inverse relationships. We talked about direct variation. I don't think we talked about inverse. A force of 50 pounds applied to the lever 36 inches will move the rock. Which function models the relationship between F, the amount of force applied to the lever, and D, the distance? We didn't do inverse relationships. So I'm just going to skip this because you're not going to be tested on it. So move on. Number 21. Which statement about the quadratic function below is false? False. The graphs of two of these functions have a minimum point. So if it has a minimum point, that means it looks like this, which means it has a positive coefficient. This one will be upside down. This will be upside down, and this will be right side up. So that doesn't make any sense. Letter B, the graphs of all these functions have the same axis of symmetry. Well, in a second we can put it in the calculator to check. The graphs of two of these functions do not cross the x-axis. We can check. The graphs of all these functions have different y-intercepts. Well, we can check. But it's asking which one is false. And we already know that these two have maximum points, only one of them has a minimum point. So if it's asking for false, we actually already know the answer. But I'm going to be thorough. -3/4 x squared plus 6. -2x squared minus 5. 1/4 x squared plus 1. Okay. The graphs all have the same axis of symmetry. They all have the axis of symmetry as the y-axis, so that is true. The two of these functions do not cross the x-axis. This one doesn't cross it, and this one doesn't cross it, so that's true. The graphs of all these functions have different y-intercepts. This one crosses here, here, here. That's true. So A is the only one that is not true. What are the solutions to the equation x squared minus 4x equals -1? So this should look kind of familiar to you. It has done the -b plus or minus square root of b squared minus 4ac. This is on your formula chart. Remember, the only way we can use this is if this is equal to 0. So to make it equal to 0, I have to add 1 to both sides. So I'm working with x squared minus 4x plus 1. So my a is 1, my b is -4, and my c is 1. So when I replace this with a -4, It's actually going to turn positive. So I can already cross out those two. Plus or minus negative 4 squared minus 4 times 1 times 1 divided by 2 times 1. So then inside the parentheses, 4 squared would be 16 minus 4, which is the square root of 12. So the answer is G. If you don't multiply this right, you would get plus 4 right here, which would give you this answer, but that is not correct. The answer is G. Number 33, which graph can be obtained by translating this graph down 7 units? So I have this graph down 7 units. So I take this plus 2 and I translate it down 7. So I have 2 down 7, which would be negative 5. So the y-intercept is now at negative 5 rather than at 2, which would be C. You could even put this in the calculator just like this and then do the minus 7 at the end and see what the graph looks like. That's a strategy if you're not sure. Or put that original equation in and see it and then think about moving it down 7, what it would look like. There's all kinds of things you could do. Number 40. Which statement about the quadratic equation below is true? All of these are talking about its solutions. So it wants to know the solutions. So we might as well solve it. I'm going to put in the calculator to solve it. So we have negative 4.5 x squared plus 72. And if I look at the graph, I have solutions at 4 and negative 4. No real solutions, it would just not cross the x-axis at all. We're at 0. Infinite solutions doesn't make sense for this type of equation. And if it was only at positive 4, the vertex of the parabola would be at positive 4. But you can go back and look in the table. And we have a 0 here at 4. You can't see that. A 0 at 4 and a 0 at negative 4. So the answer is H. Number 43. An architecture student is drawing a graph of an arc. As shown below, the arc has a shape of parabola that begins at the origin and has a vertex at 4.6, 12.2. Other than the origin, at what point will the graph intersect the x-axis? So if this is at 4.6, remember that everything has to be symmetrical. So the 0 right here is 4.6 units away from the origin, which means this 0 has to be 4.6 units away. So 4.6 plus this would make it at 9.2. You could also kind of sketch out where these are. So this would be 4.6. It doesn't make sense for it to cross here if my graph is going like this. And then 12.2, that just doesn't look like it's going to be, that's not going to be symmetrical. And 10.6, again, wouldn't really be symmetrical. It's closer, so those might be your kind of best guesses. But if this is symmetrical all the way down, this has to be the same distance as this, which is 4.6 away, which is how I got 9.2. And your final question, which expression is equivalent to this? So when we are multiplying, our exponents need to be added together. so we'll have a plus b. And then when we divide, we subtract our exponents, so we'll have to subtract the c, which is how we get h. And that is the end of the video tutorials. I hope that it was helpful, and I'll see you in class.